This is the solution video for section 5.3, problem number 1. All right, so we are given that v is equal to negative 5p to the 3 halves, and dv dt equals negative 4 when v equals negative 40. Find dp dt. All right, so if we're going to do this, okay, what we need to do is we want to take the derivative, right? So the derivative with respect to time, so derivative of v is dv dt, of course, equals, all right, now I've got the negative 5 times p to the 3 halves. All right, so derivative of p to the 3 halves would be 3 halves p to the 1 half times the derivative of p, which would be dp dt, right? Now, it says to find dp dt, so we want to solve for that, right? But in order to do that, we need to know p and we need to know dv dt, right? Now, we're given dv dt, but we don't know p. So here comes in where we need to use v. So we're given that v is equal to negative 5p to the 3 halves. And so if v is negative 40, then we can say, okay, negative 40 equals negative 5p to the 3 halves. And now I need to solve for p. So I'm going to divide by negative 5. All right. And so 40 over 5 is 8, right? So 8 equals p to the 3 halves. All right, so how do I get rid of the 3 halves power? Well, I'm going to raise each side to the 2/3 power, right? And so remember, when I raise to the 2/3 power, the reason we're doing that is because we would multiply these powers and we'd be left with p to the first, right? So 8 to the 2/3 power is the third root of 8 squared, right? So I always do the root first, right? And so the third root of 8 is 2. 2 squared is 4. So p is 4. So then we're going to take p as 4 and plug it in here. All right, so dv dt is negative 4. All right, then I have negative 15 halves times p, which is 4 to the 1 half times dp dt. All right, and so now I want to solve for dp dt, but I can simplify a little bit. 4 to the 1 half is just 2, and so 2 and 2 reduce, and so I'm left with negative 4 equals negative 15 times dp dt, and so in order to solve, I divide by 15. So dp dt is equal to negative 4 over 15, or 4/15, right? And so that's it. So this one is not in a context, but it was just meant to kind of help you understand the mechanics of the related rate.